Good morning. So today we're going to be looking at some applications of derivatives, so how they can be applied to kind of a real life context. Okay, so here we have an example. The shape of an artificial ski slope is described by this function. Okay, so h of d equals 4d minus 2d to the power 3 over 2 divided by the square root of d. So d is the horizontal distance in meters and h of d is the height in meters. This is what the graph looks like. Okay, so what we're going to be doing here is to calculate the gradient of the slope 4 meters horizontally from the start of the slope. Now again, this should be a trigger. The gradient of a curve, the gradient of the tangent to the curve, this is a trigger for differentiation. So this is a very complicated function to differentiate within this context, but this is what we're having to do here. So there's no mention of differentiating. You have to recognise the context yourself, the gradient of the slope, gradient of a curve, okay? Gradient of a tangent to the curve, this is something that has to be a trigger for differentiation. Okay, so we know that the gradient of the slope is the derivative of the function, which is going to be h of d, okay? And we're going to be finding the gradient of the slope at the point where d equals 4, which will be h dashed of 4. Right, so if the function is given here, we have to fix this up before we can differentiate it. So just like we did in the last set of examples earlier on, we have to separate it all and make everything individually over d to the power of a half. Okay, so this is an example of dealing with quotients where we have to divide everything out separately. Then we have to simplify the d in the top and the d in the bottom. Remember, you divide your letters, you subtract your powers. So we've got a 2 over 2, that would be a 1, a power of 1, which is a 2 over 2, take away 1 over 2, which would be 1 over 2. And for the next one, we're going to have 3 over 2 take away 1 over 2, which is just 2 over 2, and that's just simplifies to 1. So we just have that as a minus 2d, which is to the power of 1, but we don't write the power of 1 in there. So we're now ready to differentiate it and write h dashed of d. So we're going to do 4 times the half. So I'm not really writing it all out this time. 4 times the half, which is 2, and then subtract 1 from the power, which is minus a half. And then that's just going to be a minus 2, and the d becomes a d to the power 0, which means that the letter disappears. So that's our new derived function, but we're going to be substituting in the number 4, so we really need to get this fixed up so we can put the number 4 in, because it's hard to be able to think what d 4 to the power negative a half is, but once we turn it all back to surds again, we can do that. So we take the d down the bottom and make the d to the power positive a half on the bottom, which then allows you to make it the square root of d. So that's 2 over the square root of d, take away 2. And we're now going to substitute in the number 4. So it's 2 over the square root of 4, take away 2, which is 2 over the square root of 4 is 2, take away 2, which is 1, take away 2, which is negative 1. So h dashed of 4 is equal to negative 1. And then remember back to the context of the question, the gradient of the slope after 4 meters is negative 1. Okay. Right, so there's going to be a variety of different contexts here, and we're going to look at exercise 6H, questions 1 to 14. And again, ask your teacher if you need any help. Take care and good luck.